Hello, welcome to 2.5 and 2.6. And today we're going to expand on that power rule, get a little more practice, work with some functions that are a little more complicated, and learn to write the tangent line, or continue to learn to write the tangent line. So the first thing we get is a rule about sum and difference of derivatives. And by looking at our rule here, it says if I'm taking the derivative of two functions that are either added or subtracted together, it's like I can take each individual derivative and then add or subtract those derivatives. So not a difficult rule at all, kind of intuitive, I would say. Example 4, so find the derivative, simplify the function algebraically first. So let's take this function and simplify it. It is division. If you wanted to, you certainly could send x through, but most of us would probably prefer to use multiplication. So that's what I'm going to do. I'm going to say f of x, and here I am simplifying. So we're going to simplify. F of x equals, let's write x from the bottom as x to the negative 1, and then distribute it through our polynomial. Distributing it through, we add the exponents, so we're getting an x squared, a minus 4, a plus 5, x to the negative 1. Now we're ready to take the derivative. So to take the derivative, we're going to use the power rule. We're going to reduce it by a power, bring the power down. Remember the power rule, n, x, n minus 1 is the derivative, okay? So that's what we're going to do. F prime of x equals, the 2 comes down, reduces by a power, leaves us x to the first. The derivative of a constant is 0, and the derivative would be negative 1 times 5, negative 5, x to the negative 2. Do not leave a negative exponent in your answer, so let's write this with bouncing it to the bottom. And there's our answer. Not so bad. The next one is a product rule. So let's take and multiply this first. Let's simplify our algebra by foiling it out or distributing it. So g of x equals x cubed minus 3x squared plus x minus 3. I couldn't read my writing on that one. It was plus x, wasn't it? There we go. Plus x minus 3. Now we should be ready to take the derivative because we're in a polynomial, and taking derivatives of polynomials is very easy. The power rule, 3x, reduce your power by 1, 3x squared. 2 comes down, multiplies by the 3, and we're at 6x. The derivative of x to the first would be 1, x to the 0, but x to the 0 is going to be 1. And the derivative of a constant would be 0. So I'm not going to write that, especially because it's at the end. And there is our derivative. So A and B, super nice. They look complicated, but we could turn them into something easy. When I look at C, it looks kind of complicated. I've got to cube this out. And unless you remember the Pascal's expansion, the binomial expansion, where you wrote the triangle, you might be able to figure out your coefficients and the positive negatives. If you don't trust yourself, well then let's just show we're cubing this, and let's start by foiling two of the terms, or two of the factors together. So I'm going to have f of x equals x squared minus 3x plus 9. Gets multiplied by an x minus 3. But first, I think I want to take the step and simplify the first. X squared minus 6x plus 9. If you could do that all on your own the first go through, good for you. Now, let's take and distribute. So f of x, I am going to take x squared times each of those terms. So x cubed minus 3x squared. I'm going to take 6x times each of those, minus 6x squared minus 18x. I'm going to take 9 and multiply, it looks like it's positive, times both of those. Simplify it. Oh, it's a lot of work cubing things. X cubed minus 9x squared I'm getting a minus 9. I'm just wondering if that's right. I think that should have been positive. Yeah. Positive there. So how about a plus 27x? And then last times last, oh, a minus 27 was negative 27. Got it. Just checking to see if I have everything the way I thought it should be. Get the x cubed, a minus 3x squared. This term I did not have before, but I should have, I think. Yeah, hopefully that's all correct. Okay, so f prime of x. If you see a mistake, correct it and then take your derivative. Now I'm going to go 3x squared minus 18x plus 27. And there's that derivative using the power rule, and you're done. The next one, once again, like we did on A, where we called this x to the negative 1, let's do that for this one. So for D, let's write this as g of x equals x to the negative 1/2, because it's coming from the bottom, 2x squared minus 3x. Distribute through, we're still just simplifying. You can tell because I'm still just working with the regular function. Distributing, I'm going to get a 2x. 2 plus a negative half leaves me 1/2. I'm going to write it as 3/2. Minus 3, x to the first plus a negative half leaves me a positive half. And now I'm sitting in a pretty nice position to go into the derivative work. So the derivative g prime of x, make sure you write that. 3/2 comes down, multiplies by the 2, doesn't it? And then I reduce by 1, which I'm going to write 2 over 2. 3, or let's say a half comes down, multiplies by the 3, x to the 1/2 minus 1, or 2 over 2. And now I'm just going to simplify out what I got there. These 2's will cancel. I'll get 3x. 3/2 minus 2 over 2 leaves me 1/2. Minus 3/2 x to the negative 1/2. Oh, I can't leave a negative exponent. Bummer. 3x to the 1/2 minus 3 over 2x to the 1/2. And game over. We got it. When we flip to the back side of these notes, we are writing the equations of the tangent line. Such an important skill to know in AP Calculus. So we're going to write the equation of the tangent line to the given function. And my function is just 2 terms, and then they give me the point of tangency. Oh, sorry, my lights just went off again. They do not stay on very long. So hopefully, I'm kind of in the dark, but that's the way it's going to be. All right, first thing I know I need is the derivative. The derivative f prime of x equals 1 minus 4x. I need to know the slope at x equals 1, at that point of tangency. Because in order to write a linear function, I need a slope and a point. All right, I got the slope, or I don't have the slope, I need to calculate it. Oh, you know what? Let's write the word calculate in front of here. Calculate slope. So f prime, the way I'm going to show I'm calculating at 1 is I'm going to go f prime of 1. Substituting 1 in this function, this derivative function, gets me a negative 3. If I can move that and get a little more light. And I have my point, the point of tangency. Now, combining this, write the equation. Write the equation of the line. y minus y1 equals f prime at x sub 1, x minus x sub 1. That's really what it takes to write the equation of a tangent line. We had our point and our slope, so let's grab those and away we go here. Y plus 1, because it was minus minus, equals negative 3 x minus 1. Fantastic. You may leave it in that form, or if you wanted to, you could transfer it over into y equals mx plus b, but why risk making a mistake? So I'm going to leave it. Here's what the picture of the graph looks like. We had a parabola that was facing downwards. We can see that. And here's our point, 1, negative 1. And our green line is the equation of the tangent line. And it looks perfectly tangent. Fantastic. Part B, write the equation of a tangent line to the given function. Same steps as last time. So, only problem is they gave us the x value for the place of tangent C. So we have to do a little bit of work, don't we? We got to get the point. So let's go find the point. Because an equation needs two things, a point and a slope. When x equals 1, what is y? Well, I plug it into my function, f of 1, and I get 2 square root 1 gives me 2. All right, I now know the point. It's 1, 2. Hang on to that bit of information. The other thing we need is the slope. So let's find the slope by finding the derivative. And we're going to have f of x. I'm going to rewrite that square root x as a power, because with the power rule, it's much easier to find it if it's written as a fractional exponent. 2 times 1/2 x to the negative 1/2. We reduce that power. We get f prime of x equals x to the negative 1/2. That's like saying f prime of x equals 1 over square root x, isn't it? Whew. Now, evaluate. Evaluate that derivative at x equals 1. So, let me just scroll a tiny bit. F prime of 1, remember that's how you're going to notate it, so I know what you're doing. 1 over square root 1 gives us 1. We have a slope and we have a point, and together that's marvelous. Let's write the equation of the tangent line. Y minus y1 equals the slope times x minus x1. If you want to, you certainly can take it further, but by any means you do not have to. You can leave it in point-slope form. Looks like that's the equation of the tangent line. Either of these are fantastic. Picture on that one, we had a square root function. I'm just going to erase and pull this out. There's our square root function in the reddish color, and our equation of the tangent line, y equals, what was the slope of 1? Going through the y-intercept of 1. All right. I'm going to erase this ink because I think that slows the machine down because it keeps trying to save that ink with the presentation. All right, example 6. Find locations of horizontal tangent lines. Well, horizontal tangent lines, if I had a tangent line, what would it look like if it were horizontal? It would be a horizontal line. Tell me, what slope do horizontal lines have? Horizontal lines have a slope of 0, correct? So if I want to find at what points this occurs for my original function, I basically want to find where the derivative is equal to 0. All right, I like our function they gave us. So f prime of x equals 0. That's what we want to find. Let's put find in front of here. That's our task. How are we going to get there? We're going to go f prime of x equals. Take the derivative of this. And just to show you how fast you can be when you finally have practiced this enough, I have my derivative. See if you can get that. Power rule. Power comes down, reduced by 1. Pause this if you need to. Now let's set f prime of x equal to 0 so we can find the horizontal tangent line. Maybe there's more than one, because we're looking at a quadratic function which might have two solutions, right? There's a chance that it does have two solutions. So 0 equals 3x squared minus 10x plus 7. Solve this by factoring, and this is factorable. We got nice prime numbers to work with. Couldn't be any sweeter. So 3 is only 3 times 1. 7, the only choice is 7 times 1. Get them in the proper spots. Minus minus is the key here. Now set each factor equal to 0. So I'm going to have 3x minus 7 equals 0. And I'm going to have x minus 1 equals 0. Solution coming off of the first factor was 7 over 3. And the solution on the other one is x equals 1. We have two places we can expect a horizontal tangent line. Okay, so if a curve is going to have a horizontal tangent line, does it not have to kind of reach a max? Or perhaps it reaches a min in order to get that horizontal tangent line. Let's look at the case. I've got the graph here for you. Oops, they didn't work together. It was a cubic function. Looky there. 1, and then our other one, 7/3. That looks about right. 2 1/3. And then the other one was at x equals 1. We did it. Finally, last thing, ensuring tangency to a given point. Given the function f of x equals x cubed plus kx and the line y equals 6x minus 2, find the value of k so that the line is tangent to the function. Whew, I got to reread it. Sometimes you have to reread. Get your highlighter out. Highlight things that were important. Given the function, I need to know that. And we have a line. Find the value of k so that the line is tangent to the function. Well, the line that they're talking about is the linear function line, right? The linear function is the line, so that line is tangent to the function. All right, so I know I probably am going to have to take a derivative. It's a good chance in calculus. So let's take our derivative. F prime of x equals 3x squared plus k, because this is just a 1 power. 1 times the coefficient is still k. So that's our derivative. A derivative calculates slope. At a point. So they're asking us to find that point, and we know the equation of the tangent line. The tangent line given to us is given. And it is y equals 6x minus 2. If that is given to us, can I find the slope of the tangent line? Yes. This indicates mx plus b. This is the slope. Well, if that's the slope, then that's the value of f prime at k, because they want it to be tangent at k. Tangent line, you know what? Let's add in at k is given, because that's important that we recognize it. So f prime of k equals 3k squared plus k. Oh, what am I doing? Yeah, that will be okay. Find the value k. So we want to find k, and then it has some y value to it. But we know the slope, f prime at k, is 6. There we go. And I have this, so I know that f prime of x equals 3x squared plus k. Let's set 6 equal to 3x squared plus k. Solve that. Whew. Not liking that one. What do we got to do? Because we have too many variables. We got to create another function. And all I can think of doing is working with that original function. And I could solve this for k, couldn't I? And then I can write that. So let's say that k is equal to, subtract the 3x squared, we get 3x squared. And then I'm trying to write two equations. It was all going so well. Let me find the equation. F of x cubed plus kx, can also be written as x cubed plus 6 minus 3x squared x. And that has to equal 6x minus 2. Now, it is just solving it out. X cubed minus 6x minus 3x cubed equals 6x minus 2. Let's get everything over to one side, and I'm going to have 2x. I'm wondering if I did screw up a sign. That 6's I thought should disappear, and they weren't on me. But this definitely was positive 6, wasn't it? Negative 2x cubed, 6's are gone, subtract it from each side, they're going to zero out, equals negative 2. Oh, we're getting there. This is going to work. X equals 1. Woohoo! All right, x equals 1, but that's probably not k that they asked for. Find the value of k. We had an equation that related x and k. I just need to find it. And that's what I need to bring down. Oh, it won't come down with me. 6 equals 3. Oh, what was it? 3x squared plus k. K is 1. 6 equals 3. I'm sorry, x is 1. Find k. K is 3. That was a monster problem. That is very AP-ish. This trick of being able to write two equations, don't worry about that. We will get there. You'll see more of those. So that is it. I'm going to close up.